Q6999. A go-around from a poor landing approach should A. Not be attempted unless circumstances make it absolutely necessary. B. Generally be preferable to last-minute attempts to prevent a bad landing. C. Not be attempted after the landing flare has been initiated regardless of airspeed. The correct answer is B. When a pilot recognizes that the landing approach is not going well and there is a high probability of a poor landing, initiating a go-around is often the safer and more prudent decision. Safety. The primary concern during any flight operation is safety. If the pilot determines that continuing with the landing approach would compromise safety, such as in cases of inadequate approach speed, incorrect alignment with the runway, or excessive descent rate, it is generally better to go around and make another attempt at a stabilized approach. Stability and control. Last-minute attempts to correct a poor landing approach, such as aggressive maneuvering or abrupt control inputs, can destabilize the aircraft and increase the risk of loss of control. Going around allows the pilot to regain control, stabilize the flight, and establish a proper approach profile for a subsequent landing attempt. Decision-making time. By initiating a go-around early in the approach when it becomes apparent that the landing may not be successful, the pilot has more time and altitude to safely transition back to a stabilized approach or make alternative landing arrangements, if necessary. While there may be circumstances where continuing with the landing approach is necessary, such as in emergency situations or when specific factors require landing at the time, generally, a go-around is the preferred option when a poor landing approach is recognized. 7000. During go-arounds from a full-flap approach in conventional airplanes, which procedure should be used if the flight manual does not specify differently? A. Start retracting the flaps first, then retract the gear. B. Retract the gear first and adjust flaps only after reaching a safe altitude. C. Retract the gear first since it has a far greater adverse effect on aircraft performance than do flaps. The correct answer is A. When executing a go-around from a full-flap approach, it is generally recommended to start by retracting the flaps first before retracting the landing gear. Here's the reasoning behind this procedure. Stability and control. Retracting the flaps first helps maintain better stability and control of the aircraft during the initial climb-out phase. By reducing the wing's lift and drag characteristics associated with full flaps, the aircraft's pitch attitude can be more easily controlled during the transition to climb. Performance considerations. Retracting the flaps reduces the aircraft's drag, allowing for a more efficient climb and acceleration. This is particularly important during a go-around, where a rapid increase in climb performance is desired. By reducing the flaps first, the aircraft can achieve a better climb gradient and climb to a safe altitude more quickly. Gear retraction. After the flaps have been retracted and the aircraft is established in the climb, the pilot can then proceed to retract the landing gear. Retracting the gear after the flaps allows the pilot to prioritize the reduction of drag and the achievement of a positive rate of climb before addressing the gear retraction. While specific aircraft models may have variations in the recommended procedure for go-arounds from a full-flap approach, the general principle is to retract the flaps first. Q6991. To minimize the side loads placed on the landing gear during touchdown, the pilot should keep the A. Direction of motion of the aircraft parallel to the runway. B. Longitudinal axis of the aircraft parallel to the direction of its motion. C. Downwind wing lowered sufficiently to eliminate the tendency for the aircraft to drift. The correct answer is B. During the touchdown phase of a landing, it is important to align the aircraft's longitudinal axis with the direction of its motion, parallel to the runway. Here's the reasoning behind this procedure. Alignment with runway. Keeping the longitudinal axis of the aircraft parallel to the direction of its motion ensures that the aircraft touches down in a straight line along the runway. This helps in maintaining directional control and prevents excessive side loads on the landing gear. Minimizing side loads. Any significant sideways motion or drift during touchdown can result in side loads on the landing gear, potentially leading to stress on the gear components or even structural damage. By aligning the longitudinal axis with the direction of motion, the pilot minimizes the sideways forces and reduces the risk of side loads on the landing gear. Directional control. Maintaining alignment with the runway also facilitates better directional control during the rollout phase. It allows the pilot to apply appropriate rudder inputs to keep the aircraft tracking straight down the runway, reducing the potential for swerving or veering off the desired path. 6992. Under normal conditions, a proper crosswind landing on a runway requires that, at the moment of touchdown, the A. Direction of motion of the aircraft and its longitudinal axis be parallel to the runway. B. Downwind wing be lowered sufficiently to eliminate the tendency for the aircraft to drift. C. Direction of motion of the aircraft and its lateral axis be perpendicular to the runway. The correct answer is A. During a crosswind landing, it is crucial to align the direction of motion of the aircraft and its longitudinal axis parallel to the runway. Here's the reasoning behind this procedure. Alignment with runway. By aligning the direction of motion of the aircraft with the runway, the pilot ensures that the aircraft touches down in a straight line along the runway. This helps maintain directional control and minimizes the risk of drifting off the desired landing path. Crosswind correction. Throughout the approach and landing, the pilot applies appropriate control inputs, such as aileron and rudder, to counteract the effects of the crosswind. These control inputs are aimed at keeping the aircraft's longitudinal axis parallel to the runway and preventing drift caused by the crosswind. Stability and control. Touching down with the aircraft's longitudinal axis parallel to the runway enhances stability and control during the landing roll. It allows for better handling of the aircraft and facilitates smooth deceleration and taxiing after touchdown. 6996. If an emergency situation requires a downwind landing, pilots should expect a faster A. Airspeed at touchdown, a longer ground roll, and better control throughout the landing roll. B. Ground speed at touchdown, a longer ground roll, and the likelihood of overshooting the desired touchdown point. C. Ground speed at touchdown, a shorter ground roll, and the likelihood of undershooting the desired touchdown point. The correct answer is B. Increased ground speed. When landing with a tailwind or downwind component, the ground speed of the aircraft is increased. This is because the aircraft's true airspeed combines with the speed of the wind. As a result, the ground speed at touchdown will be higher than the indicated airspeed. Longer ground roll. With a higher ground speed, the aircraft will require more distance to come to a complete stop after touchdown. The increased ground speed adds kinetic energy that needs to be dissipated through braking and aerodynamic drag, resulting in a longer ground roll. Overshooting the desired touchdown point. The higher ground speed, combined with the momentum of the aircraft, can make it more challenging to accurately touch down at the desired point on the runway. The increased speed can lead to a longer float during the flare and touchdown, making it more likely to overshoot the desired touchdown point if not managed properly.